And I'm going to just go ahead and show that since my PowerPoint slides don't seem to be working properly, I'm going to just base it on this old PDF of my slideshow. Okay? So anyways, let me handle one thing first. For those people that are interested in security, I have gotten a hold of Marcus Butler, and we're going to be able to allow you to do some penetration testing or security work. For those of you that are just learning computers for the first computer programming for the first time, don't worry about it. Some of what we're covering tonight is just basic computer science, bits and bytes and stuff like that. So, some of it might be a little bit underwhelming or stuff that you had before. If not, feel free to tell jokes in chat or anything you can to stay awake. But I'll try to cover this as quickly and painlessly as possible. Did you guys get a chance to start looking at what's on the etude site? I haven't put a whole lot there, but I'll put some assignments up probably later tonight, early tomorrow, as far as reading assignments and things like that. Anyways, yeah, this is lecture 4. But anyways, one of the things we're going to look at is how data are stored or manipulated by a computer. Basic computer language concepts. What are high-level versus low-level languages? Some of this you learned in CS 901. Interpreted languages versus compiled. And what are operators and keywords and things like that. Okay. As you probably know, data in programs are in the computer as a sequences of zeros and ones. And if you think about how they work, zeros and ones represent states. Let's see if I can make this a little bit bigger. It's probably better on your screen. Okay? In other words, in the old days, you could use what was called a relay switch. Something that would click on or off, an up and down, on and off button. Vacuum tubes were used in the early digital computers. Now they're even talking about strange things about, very odd states of matter and anything where you have either, where something can be on or off. Okay. So here they show each one of these numbers. If you count, there's 8 different switches that toggles on here. Each thing can be on or off, and that's a bit, like a 0 or 1. Altogether, those 8 bits comprise a byte. Okay? And pretty much the computer's memory is divided in terms of bytes. 1 byte is large enough to store an ASCII letter in what's called ASCII standard, or a small number. And a byte can be, again, 1 byte is equal to 8 bits, and that's, you probably saw that question in CS 901. So storing numbers that on a positive charge or on position may be a 1. The off position would be a 0. And for most of us, how binary numbers worked, again, that first number to the right is 2 to the 0 power, or 1. 0, in this case, is 2 to the first power. So it's kind of like if this was a decimal number, the first number, this would be the ones. The second number to the left would be the tens, the hundreds, the thousands, the 10,000s. But in binary, this is the ones, the twos, the fours, the 8s, the 16s, 32. I always tell a joke of why, that you have to be careful when you talk to a computer scientist, because you can say, well, what one person asks the other, how many lovers have you had in your life? And the person says, I can count them on one hand. Okay, so with 5 fingers, how many numbers could that be? Well, it could be 1, 2, 3, 4, 5, if it's base 10, or in binary, if he puts all 5 fingers up, that could be 31. And 1 plus 2 plus 4 plus 8 plus 16. Okay. So in other words, here they have on the right side this 1 0 1 0 0 1 1 1 0 1 is 1 in the 128th place. 0 times 64 plus 0 times 32 plus 1 times 16 plus 1 times 8 plus 1 times 4 plus 1 times 2 times 1 times 1. By the way, what would happen if I add a number here to the right of the 1? What would that be? Anybody? You want to try typing that in chat? No. To the right of it, remember this is the 2 to the first power. 1 is actually 2 to the 0 power. So what would the next one be? 2 to the what power? Yeah, Hidalgo has it correct. It would be 0.5. It would be 2 to the minus 1 power. What would the next one be? If I had 1 1 here, what would the next number be? Well, one moment, I'm going to have to step away for a second here. Yeah, it actually would be, if it was 1 and then 1 1 after that, to the right, it would be 1 times 10 to the minus 2 plus 1 times 10 to the minus, let's see, I have 10 to the minus 1 and 10 to the minus 2. So that would be 1/4 plus 1/2, so it would be 3/4. So nice try, folks. If it was 0 1, so it was 0 times 0.5 plus 1 times 0.25, you'd be absolutely correct. So it's 0.75. Yes, Julie. We'll do a little bit more about that later. I'll put some assignments together. This is just the first lecture of it, and we're just kind of easing our way into it. So, kind of relax about it. So, so the largest byte value that can be stored in a single byte with 8 things on was 255. 128 plus 64 plus 32 plus 16 plus 4 8 plus 4 plus 2 plus 1 is 255. If you say 2 bytes, well, that number goes to 65,535. Okay, So again, don't panic if you haven't seen this before. Yeah, it's okay that kids that are, second grade or third grade kids are learning this stuff, but we don't deal with this all the time. And fortunately, you don't have to. Okay, there will be some problems, and you will learn it. It's good to know. Okay. What about characters? Okay. Remember, bit patterns are used to represent characters. And they're stored just like numbers are, but a binary pattern is going to depend on the type of data it represents. For example, you can have the number 65 in binary. It could be the number 65, or it could be the capital letter A. And they have two different schemes. One is called, or there's more than two schemes. One is called ASCII, which is a set of 128 numeric codes that represent English letters, various punctuation marks, and other characters. In other words, with 8 bits, or 1 byte is 1 character. Okay. Then you have what is called EBCDIC, EBCDIC. Back in the old days, IBM always had to do its own thing. And so it had a standard called EBCDIC, which was another way of representing numbers. Something that we're using more and more commonly, instead of ASCII, is something called Unicode. Unicode uses 2 bytes for each letter. So as you can tell, there's 65,000 different characters that you can have. Okay, it's pretty much becoming the standard character set. Python does support Unicode. In fact, the first 127 Unicode characters are the same codes they are in ASCII. It's kind of an extended ASCII. They said in the days of the old, these are old computers, the PDP-8, the PDP-11, which are still around in the 70s, how you used to have to program these computers to get them to start up was there's like these, it looked like switches like this. And you would have to click these switches up and down and push a button to enter it. So another set of buttons and enter it. And that's how you would bootstrap the computer. There were no hard disks back then. Okay, I'm going to not introduce Python right now. I'm going to leave that to your, we will be doing that next time, but part of what I want you to do is to go into the interactive Python and do the first chapter, that first general introduction to Python. Okay, and I'll post this up in eTudes. But I want you to go through those exercises. There's only a couple of things that have to do with programming. And you'll do your first program, which is just simply saying, print hello world. Okay. Now, in Python, the source code or the instructions are written in the Python language in text. And that text file is saved with a .py file extension. Okay, that's the source code for Python. However, when the program actually runs, the CPU only understands the instructions that are given to it in machine language, which are binary. So you have to have programs, something that translates the program from what you wrote that you can understand to what the machine can work with and understand. So at this point, we have to digress and talk about high-level and low-level languages and how different computer languages are translated. And if it can't be translated into a machine language, it can't be run. Okay. So we have two levels of languages, high level and low level. In the beginning, all the programming was done in machine language. In fact, they still do. There's still certain people that still like to code in machine language. Why? Because it's fast. The good news is it's really fast, and you can write really small, tight code that doesn't take up too much space. Well, the problem is now, memory is cheap, processing power is huge, and we don't have to, save the space, our memory, and we don't have to, we have CPU cycles to burn. The problem with machine language is it's unique to the computer and the processor. So if you have a different motherboard or with a different processor on it, you can't run the program. So the machine language, from beyond a machine language, you had something called assembly language. And what that was a language that would make the programmer's life easier by having commands like add, so that some kind of mnemonics, like the word add, represented a set of machine language instructions. Okay, and that's from which all the programming went from there. It's easier to work with, but a computer can't directly translate instructions. Something called an assembler is required to translate that program into machine language. Now, assembly language is considered one of the lowest levels of language, because low, when they mean low, it means the lower the level of language, it means the closer it's getting to the machine language. On the other hand, Java is a high-level language. Python is a high-level language. BASIC is a very high-level language. Okay. High-level languages are easier to understand. They're more English-like. Some examples are Ruby and Java and Fortran, C#, Python. They all have other features. And the translation process is more involved in a high-level language, so programs may take longer to execute than those written in a low-level language. It all depends on the compiler. In Python 2, if you, just to show that thing hello world, you just say print hello world. Doing the same thing in assembly language would require many instructions to make that work. Isn't it 0.25, 0.125? No, because that's 0.25. The first thing on the other side of the 1, del doggo, is the 10 to the minus 1. So it'd be 1 times 2 to the minus 1 plus 1 times 2 to the minus 2. So it'd be 1/4 plus 1/2. Sorry about that. I hadn't seen your chat question response. Okay, so we have compilers and versus interpreters. Okay, you write the statements in some sort of high-level language, and that's called source code or code. Okay, your source code is then translated to machine language using either what's called a compiler or an interpreter. Python is interpreted. Okay. A compiler is a program that translates a high-level language into a separate machine language program and typically compiles down to like a .exe file or a .com file. Python is not compiled. C is compiled, C++ is compiled. And so here's an example in the picture. A compiler is used to translate it. So like print hello, everything. It goes to the compiler and comes out as machine language. And that machine language could be, a .exe file. You just send it to the CPU and it runs. An interpreter both translates and executes the instructions in some sort of high-level language. So in other words, in this particular case, your program is interpreted that kicks out machine language that then goes to the CPU. But the program itself is not stored as executable binary. When we learn to program, we have things that are called keywords, operators, and syntax. Keywords are reserved words or words that have special meaning and purpose in language. In other words, if I said, plus, if I use the word plus, while it may mean certain things that are reserved in the program language, like adding two numbers together, you might use the plus, the equal sign. You can't redefine those signs because those are reserved words or keywords. Okay. When I say print hello world, print is a reserved word. So those are the language, the command languages, and you have to be careful not to create variables with the same name or to confuse the program. Besides keywords, you have things called operators. Operators are like arithmetic operators that perform various operations of the data, like raise to the power, plus, minus, times, divide, And we'll learn more about Python's operators. Syntax, when you think of the word syntax, think about grammar. You have to follow certain conventions as far as indenting, as far as how you say this equals this plus this, whatever, however you say it has to be done in a certain way. If you don't do it a certain way, the interpreter doesn't know quite what you mean. So the syntax is that rule, the grammar of a computer program. Statements are the individual instructions, like print hello world is a statement to write a program. The program statement consists of keywords, operators, punctuation, and other programming elements. Okay, I mentioned this in the orientation. This is a 2010 slide. But Python was developed by Guido van Rossum, first released in 1991. The official symbol is a little green snake. So let's see. The official website is python.org. It's used a lot for web and internet development. Like I said, it's used by Google in its web apps, in its application environment, databases, desktop, scientific, education, gaming. In gaming, you've probably heard the games like EverQuest, Battlefield 2, Civilization, Disney's Toontown Online. It's used for software development, network programming. Some companies, of course, is Google, NASA, Microsoft, Industrial Lights and Magic, i.e. Star Wars. I mentioned the other day that I had read that at one point Industrial Light and Magic had 700 Python programmers working for it. I use it over at JPL. So why use Python? Python is a minimalist approach. There's only one way to do something. It's an easy language, easy to learn, easy to use, and to bridge the gap between the programmer and the computer. It's simpler and clearer than some of the high-level languages such as Java and C++, and just as powerful, if not more powerful, because the libraries are out there for it. So why use Python? It's easy to use, and the quote is programming at the speed of thought. It increases productivity because it's 3 to 5 times shorter than Java. Your Python program will be 5 to 10 times shorter than C++. The shorter and easier it is to understand these programs means that programmers have to spend less time debugging and more time creating. So some examples are this. I can just say print, game over. Or under C++, you have, 1, 2, 3, you have all these lines of code to do the same thing as a single line of Python. And under Java, here's a minimal program to do the same thing as well. It's really good when you have simple, easy to understand code, and you can have more than one person working on it. Okay. Python can be what they call object-oriented. Okay, there's two real programming methodologies in the world. One is called procedural, where it goes, step by step that most of us use it, and the other is object-oriented. And we will go through that at a later date. But procedure programs comprise of many functions or methods that pass data between each other. It's a structured format. This approach is shown to create problems with readability because you're jumping between different modules. Object-oriented programs define problems in terms of objects, which are, quote, instances of user-defined data types. About that point is when my eye used to glaze over when I talked about object orientation. Basically what it's like saying is you're building it into blocks of code that talk to each other, that communicate with each other. You can write Python without object orientation, or you can write it with object orientation. That's up to you. The other thing is it's considered a glue language. You can easily integrate it with other languages like C or C++ or Java. You can reuse existing code. Like I said before, a lot of times you can, you want to do a particular problem. Why reinvent it from scratch? You can go on the internet and see what somebody else has done. So, for example, as they're mentioning, Disney uses, when they created Toontown Online, they used Python for the game logic and C++ for CPU-intensive, like things like graphics. The thing that's neat about Python is free and it's everywhere. I know I must sound like an evangelist, but it runs on Windows, it runs on DOS, it runs on Mac OS, Linux, just about everything. It runs on Raspberry Pis. And so the language is independent of the processor. Python has a really strong community. You really haven't probably heard of as much about it as you could. It's an approachable language in that people can learn. Really, if you know a little bit about programming, you could learn it, like they say, one of those learn in 24 hours and actually get something useful done. Okay, so it's free and open source. I want to talk about, open source. The source code is available to the general public for use and modification of its original design free of charge. But if you put it back up, you do something with it, you're supposed to contribute your code and your improvements to other people for free. One moment, please. Okay. And there's a lot of support available on the internet. You just look up Python, you'll see there's a ton of stuff available. In installing Python, like I said, you can run on before you can run on any Python programs on your computer, you have to install the Python interpreter. And the one that we have, we're not doing with a CD. Use the stuff that's on your flash drive. Speaking of the flash drive, that for some reason didn't completely upload properly, so I'm out of town. I'm in San Francisco right now, so you're going to have to wait until the weekend to get it. Okay. Anyways, I'll put this PDF file up on the website so you can actually read this, but these are some instructions on how to get and install Python if you wanted to install it on your own computer. And so you have something called idle, which is kind of the graphical it's an ugly graphical user interface for Python. You have module docs that are in the installation, which tells you about what's in their library and what's in their standard library at least. You have the command line version of Python, and you have there's some manuals there, but that's what comes with your Python installations when you download it from python.org. I'm not going to go through all these things step by step. You can look at those a little bit later. Okay, one moment. I'm going to switch off this for a second. You know what, folks? Can you hear me? Okay. I'm going to, it is now 8:30. We're going to call this lecture a little bit short today. All right? I don't want to get into the next thing. We'll do another lecture on Wednesday, starting about the same time, about 7:30 to 7:45. Okay, and for those of you that are listening to the recordings, we will, anyways, look on eTubes. It may not be up there until later tonight. Like I said, I'm in seminars here, but there will be some assignments on there of things to do. If you're going to do anything, do the interactive Python and work on the general things. So that should take you no more than about an hour or two to actually do that thing. Just the general section. All right, so what we're going to do is we're going to say good night all. Using the class summer 2030. Yeah, you can try it, see what happens. Okay, good night. I'm going to figure out how to stop this thing from recording. Testing, yeah, okay.